how do cars weighing several tons stop with just one brake application. Today, we'll go into detail about how a car's braking system safely brings the vehicle to a stop, and the differences in braking systems between gasoline and electric vehicles. First, when we step on the brake pedal, there's a vacuum booster pump behind it. This pump amplifies the force from our foot on the brake, thereby pushing the piston in the master brake cylinder. A reservoir is located above the master cylinder and it holds the brake fluid. When the master cylinder piston moves forward, it squeezes the fluid in the reservoir. Since brake fluid is incompressible, it flows through the lines to the brake calipers on all four wheels. The brake caliper also has a piston structure, where the piston and the caliper are integrated.
Brake calipers are equipped with brake pads on both sides, and these brake pads are the essential components responsible for generating the necessary braking force. When the hydraulic fluid pushes the pistons of the caliper outward, it then compels the brake caliper to firmly grip the central brake disc. Due to the brake disc being rigidly connected to the wheel, it rotates synchronously with it. When the brake caliper clamps down, the brake pad will then generate friction with the brake disc. This friction is the braking force that we generate when we step on the brakes. This braking force then grips the rotating brake disc, which in turn prevents the wheel from spinning quickly, ultimately causing the vehicle to slow down. The tighter the brake caliper clamps inward, the greater the friction between the brake pad and the brake disc, and the stronger the braking effect will be. This is the fundamental working principle of a hydraulic braking system. The braking difference between fuel and electric cars lies in the booster pump behind the pedal. The most common on fuel cars is the vacuum booster pump. Inside, it's divided into two chambers separated by a rubber diaphragm. The vacuum chamber near the engine connects to the intake manifold via a vacuum tube. When the engine operates, negative pressure from the intake stroke creates a vacuum environment for both chambers. Note that if it's a turbocharged or diesel engine, due to their specific operating characteristics, the intake manifold cannot provide sufficient vacuum. An additional vacuum pump is therefore required to assist in creating the brake vacuum environment. When the brake pedal is depressed, the chamber closest to the brake opens an air valve, allowing outside air to enter, causing the pressure inside the chamber to rapidly increase to atmospheric pressure. This instantly creates a pressure difference across the diaphragm, pushing it towards the vacuum chamber, which then moves the brake master cylinder piston. This is the source of the power assist when we press the brakes. So, when driving downhill, never turn off your engine for the sake of so-called fuel economy. Because with the engine off, no vacuum assist is generated, the brakes become very stiff, impossible to press, and that's extremely dangerous. Modern pure electric vehicles have no engine, so how do they achieve brake assist? Actually, electric cars replace the original vacuum assist pump with an electronic one, using electronic control to create vacuum instead of the engine, achieving the same assist. Some high-end electric vehicles also use an electronic hydraulic assist system, which directly eliminates the vacuum assist pump. It transmits commands via electrical signals, using a motor to drive a hydraulic sub-pump for braking. Furthermore, with the advancement of electrification, many gasoline cars now also directly use electronic vacuum assist pumps, especially small displacement turbocharged models. This not only prevents situations where turbocharging intake cannot provide sufficient vacuum, but also reduces engine load and lowers fuel consumption. On some high-end or commercial electric vehicles, brake-by-wire is used directly, which is pure electronic mechanical braking. Its principle is to completely eliminate the hydraulic system. Each wheel has an independent motor directly driving the brake caliper. By connecting to a sensor on the brake pedal, it identifies the depth of each press, transmitting an electrical signal to an electromagnetic pump to control the wheel's braking force. Many people worry that electronic stability isn't as good as pure mechanical, and the chance of brake failure will be higher. At this stage, this issue truly cannot be fully avoided, but the cost of electromechanical braking is higher, so it won't be mass-produced, and we generally won't use it. Just for your information. Also, regarding a car's handbrake, it's mainly for securing the vehicle when parked or for low-speed emergencies. It handles parking, and the foot brake, which handles braking while driving, are completely separate systems. The handbrake's braking force primarily acts on the rear wheels. Handbrakes are mainly categorized into two types: mechanical, using a cable pull, and electronic. A mechanical handbrake's lever has a ratchet system underneath. Pulling it uses the ratchet's leverage to control two steel cables, locking the brake pads and discs, thus achieving the parking purpose. The electronic parking brake has a motor installed on each side of the rear wheels. When the button is pressed, an electrical signal controls the motor to push the parking piston, locking it to create braking. But whether it's a mechanical handbrake or an electronic one, they are both independent of the main braking system. If the main brake fails at low speeds, the handbrake can be used for emergency situations. However, at high speeds, never use the handbrake directly, because the instantaneous lockup of the rear wheels will directly cause the vehicle to lose control, fishtail, and overturn. If you want to adjust the strength of the braking force, the design of the brake structure is absolutely crucial. In our next episode, we'll deeply analyze the structure, pros, and cons of disc and drum brakes. If you're interested, please hit the follow button. See you next time. Dai ya, pasasas.